There is one kind of test my engineering team lives on, and AI can't fake it. It catches what unit tests and integration tests miss, and AI code review approves anyway. It's an acceptance test written in a specific way. By the end of this video, you will know how it maps AI-generated code back to the original business intent and how to install it on your team. Your team is shipping with AI right now. The unit test pass, the CI is green, the AI code review tool approved the change, but the product still has bugs that the spec would have caught. And you feel it in support tickets, bug reports, in the gap between we tested it and it works. The problem is that this gap, it's widening with the AI. What I see across the team's eyelid, most people frame the verification as the testing problem. But in my view, it's an alignment problem. Automated acceptance tests written in a specific way act as an alignment layer between what business actually wanted and what the AI actually shipped. Same artifact that most teams already have, a different mental model. And a mental model is what survives the AI iteration. I run Team Brilliant, 20 senior engineers shipping with AI to client products every day. And this is the only pre-production check that I trust on a real AI shipped work. Today we're talking about 4 parts. 1. Why every other test breaks under AI. 2. Acceptance tests as an alignment diagram. 3. The 3-layer structure that keeps that alignment durable. And 4. Separating the context, the AI error discipline. And at the end is the leader's decision how to install it on your team. Why every other test breaks under AI? They all have the same structural problem. The test was written by something that already saw the code, or by something that has the same context as the thing that wrote the code. In this case, the test mirrors the code. So when the code is wrong, the test is wrong in the same direction. And AI, it just accelerates this. Same AI session that writes the feature, writes the test, both align with each other, and neither aligns with what the business actually asked for. The test pass, PR ships, and the bug stays. What I see, call that what it actually is, the alignment problem. The test is aligned to the code and the spec is invisible to it. An acceptance test done right acts as a contract between the expected product behavior and the actual product behavior. Spec on one side and code is on the other. And the test, it really binds them. When the test mirrors the code, it's like the same party signs both sides of the contract. And I'm so tired of seeing AI writing more unit tests. It just gives you more green check marks, but doesn't increase your trust to the quality of the system. Pull your last AI-generated PR. Find the unit tests that were generated alongside the feature. And ask yourself one question. Where did the test get its own assertions, either from the code or from the spec? If you can't tell, it came from the code. A test written from the spec reads like one. You would know this. So that's the trap. And the way out is a different kind of test entirely. The type of test that's aligned with the thing that AI can't see. There is a book I keep coming back to. It's called Mapping Experience by Jim Kalbach. He writes about a discipline called alignment diagrams. Visual maps that show the relationship between what an organization intends and what actually happens on the ground. The point is that drawing an alignment diagram makes the gap visible. The diagram is just a vehicle. And once the gap is visible, you can act on it. So for me, an acceptance test is an alignment diagram, but in executable form. Test suite equals the diagram. Pass or fail, it's an alignment status. So when the implementation changes, the diagram still stays. That's the mental shift that survives AI iteration. Alignment diagrams have 3 pieces. Organizational perspective, what the business wants. System perspective, what's actually happening. And the diagram itself, which is a translation layer between them. So apply that to acceptance test. Organizational perspective is the test case because it's written in the business language. System perspective is the API layer, which observes what the running system actually does. Translation layer, the DSL, the vocabulary that bridges the two. Same structure, same purpose, now executable. AI generates code from business intent at machine speed. An acceptance test written from the spec tests that code against the same business intent. If the AI didn't actually deliver the business outcome, the alignment fails. The alignment is the log and the spec is the key. AI can't ship a feature that works against a test unless it actually delivered what the business has asked for. Read the test case out loud to a non-engineer and they will know what it does. Customer adds items, applies the promo code and sees the discounted total. And that's your alignment diagram, but executable now. On one product, we used the acceptance test to validate the post-processing of Shopify order orders to the warehouse system. They caught issue after issue, the unit tests were happily green-lighted. And that's when it really clicked for me. Same tests, but written from the spec, doing the alignment work that unit tests couldn't. The contract had two real parties, and each test run was the interaction between them. The expected behavior meets the actual behavior. And the problem is that unit tests, they had no such interaction. And here is the structure that keeps the alignment from collapsing the moment you start working through scenarios. So 3 layers, and each layer has a different job, different rate of change, and a different audience. The structure is what makes the alignment durable. Without it, the test drifts back to mirroring the code and you're back to square one. Most teams that try the acceptance tests, they get this part wrong. They write the test case and the API layer together and they skip the middle. The middle layer is the load-bearing piece. Get it right and the alignment holds across the refactors, stack changes, AI rewrites. Get it wrong and the test just dies. Layer 1, it's the test case in business language. User adds an item to the cart, sees the correct total. It reads like a spec, never mentions implementation. It changes only when the business changes, which is slow. Anyone in the business can read it. PM, sales, support, CEO. Layer 2 is the DSL, a vocabulary specific to your business domain. It's reusable across hundreds of tests. Engineers write it, business people can read it, but that's the bridge. It changes when the business vocabulary evolves. It's slower than implementation, but faster than the test case. And layer 3 is your API layer. It's HTTP calls, browser drivers, database checks, message queues probes. The API layer is where the DSL meets the actual system. It changes whenever the implementation changes, so fast. Engineers write it, engineers read it, no one else needs to. And here is the real leverage. The test case is decoupled from the implementation. AI rewrites the feature, that's fine. Layer 3 absorbs the change and the test case stays the same. The same test that passed last week passes the AI rewritten change if the expected business outcome was completed. This type of contract is what makes the alignment durable. Most teams that try the acceptance testing, they screw up layer 2. They put implementation details directly in the DSL. Raw SQL queries, raw HTTP strings, some fixture IDs. It's just faster to write that way, so they do. AI does this by default too. You ask it to write an acceptance test and it puts in the DSL layer the raw SQL queries and HTTP calls with routes. So the DSL collapses into the API layer from day one. And that's how the alignment dies. The test case bolts directly onto implementation. Change the implementation, break the test. The test is mirroring the code again, but now with extra ceremony. Layer 2 is your business vocabulary. Defend it, hold the line. That's the structure. But here is the discipline that keeps it from getting gamed. The AI session that writes the acceptance test cannot be the same session that built the feature. Different chat only the spec and sees the API contract, but never the implementation behind it. Pre-AI, this discipline didn't really matter. The same engineer writing the feature and the test still had natural friction. Memory, second guessing, lunch breaks, and AI has none of that. It will fluently generate a test that matches its own output. No doubts, no second guesses. And this rule for me is new because the failure mode is new. So 2 contexts and 2 different jobs. The build context sees the code and the verify context sees the API contract and the spec. So PR ships when 2 things are true. The acceptance test passes against the build and the human reviewed the spec for alignment with the requirements. The human review is the log and it's a different type of review skill, checking for the spec alignment and not the implementation correctness. So the next is the workflow choice. The tool you pick sits downstream. It's the same coding agent, runs in both contexts. Claude Code, Codex, Gemini, it doesn't really matter. Engineers write the tests, QA extends them. The leader's job is to set the policy. The build a feature context is not the same as the automated acceptance test context. What I see across the teams I lead is that separate context discipline is what makes automated acceptance tests survive the AI. Without it, the tests slowly drift towards mirroring the code. Same trap as part 1, but now 3 layers deep. With it, the test is the log and the spec is the key. The build session can't fake the test and the verify session never saw the code. And the operational payoff is huge. They model state in business language. They run as part of CI. So when one fails, they give you a report. What is the scenario that broke? If you watch this far, here is the part that most CTOs never get told. The there is one thing to adopt: automated acceptance tests. The rest is the discipline that keeps them working. Frame acceptance tests as the alignment layer between AI-generated output and the actual business intent, not just more testing. And that's the lens, that's the whole video distilled. Separate the automated acceptance tests writing context from the build a feature context and train the team. And defend the DSL layer. Don't let it leak into the API layer. Pull the last 10 features your team shipped with AI. For each one, does a spec written acceptance test exist? If you can't tell for sure, that's probably no. Start with highest stakes one. Write the test from the spec. If it fails against your implementation, then you just found the first gap to fix. If you want me to install this on your team, set up the automated acceptance tests, get the DSL right. That's literally what we do at Team Brilliant. Go to teambrilliant.ai for a free strategy call. Link is in the description. One more thing, acceptance tests is just one layer of a much bigger system. The AI tools your team uses, the context they read, the verifications they trigger, they all hang off the same structure. It's called AI harness. Next video walks through what it is, how to engineer one, and where does the acceptance test sits inside it. Subscribe so you don't miss it.